Hello and welcome to this video on frameworks. Now frameworks was again a topic that was in a module called Mechanics 4 in the old A-level, but the chances are if you're watching this, you're a new A-level student, you probably won't have to do this. However, there is a reason why there is a video on it, and that's because frameworks effectively are manipulations of trig. Effectively, it's no different to an M1 problem where you have your tractor or you have your box being moved and you have to resolve forces in terms of horizontal and vertical components. The only other thing that frameworks really have with you, is they tend to be, framework questions tend to be split into two parts. They tend to have a part which is based on your knowledge of moments, which I will go over briefly, and they also tend to have, and the other half is obviously your resolving forces. Now the reason why I go over this is because it's still important irrespective of whether all of it is useful to you. Anyway, here's a question. It's from the Mechanics 4 June 2016 paper. It's question 3 if you want to look it up. Now I won't bother, in fact I will. A framework consists of 3 light inextensible rods. Rods A, B and BC have lengths 1.5 meters and the angles are 25 degrees between BAC and BCA. Framework is suspended by a vertical wire at B, vertical force of 20 newtons acts at A, a vertical force of magnitude, and then a vertical force of magnitude P acts at C. System is at equilibrium. Now, the very first thing when you attempt a framework question, or in fact any question where forces and there's rods and stuff like that, is I tend to draw 2 arrows in the middle. This will mean that the rods are in tension. This is important because normally you will assume a rod is in tension, because if a rod is in compression you can't assume its length effectively, which is kind of an important feature I feel, and that's TAC. Now the only thing you don't actually know from this is the length of AC, but we'll come to that I'm sure. Now the first question says, by taking moments find P. Now then, effectively, now moments is given by M is equal to FD sine theta. Force times distance times the angle of sine theta. Now then, we're probably going to take moments, and I use the word probably loosely, is we need to take the moments around point B, which is exactly what we're going to do. So what we can do is we can say, 20, which is our force at A, times 1.5 is going to be equal to effectively whatever that distance there is. Now if we were to draw and now we basically know from alternate angles, if that was a line there, that's 90 degrees, that's 25, so it's 90 plus 25 plus 25, which is equal to 140. So it's sine 140 times P times 1.5. which means that we can effectively cancel the 1.5, and therefore what we actually have is, assuming my calculator does work of course, but I'm sure I'll be able to find another one. Excuse me. (20 divided by 20 over sine 140) is going to be equal to 31.1 newtons. That's your answer to the first one because you need to find the force. Now B, hence state the magnitude of tension in the wire. That's easy. You know that P is 31.1, you know that 20 is down. To balance it, B must be 51.1 because you need to add the forces together. Now part C is where it gets a lot more entertaining because you need to decide whether rods are in compression or tension. Now the best way of doing that is actually to start at point A. Now effectively, if point A is in equilibrium, then you know that 20 newtons plus whatever the T, which plus that, which is going to be equivalent to TAC sine 25 because you're going the force down that way, is going to be equal to 0, because the forces down is going to be equal to the forces up. Now then, rearranging this will give you TAC, as you can see I haven't got a lot of space, so that's why I'm doing this the way I'm doing it. So it's minus 20 over sine 25. Now that gives us an answer of minus 47.3 N. Now If this would simply, now this does actually ask for the magnitude and the rod in tension, whether it's in tension or compression. Now the magnitude of the force is minus 47.3 newtons. Now then, whether it's in tension or compression, if it has a minus sign it is in compression, if it's positive it's in tension. So we know that TAC is in compression. Now I'm just going to write that at the bottom for you, in compression. So now we know that, we can move on to the next one. Now what we're going to do is we're going to look at the tension in rod TAB. Now we can do this by looking at it horizontally. If we take it horizontally around point A. So we know that TAB plus cos 25 TAC is going to be equal to 0. Now again, rearranging, etc, 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 will give us, will basically rearrange to be TAB is equal to minus 20 over sine 25. Ideally you want to keep it in exact quantities. You basically want to keep all your tensions in exact form, because it's easier and you're going to not screw up lose as many marks, which is kind of the important bit really. Times cos 25 obviously because of that, which means that it's equal to, what is it, 42.9 newtons. Which means as it's positive it's in tension, so we can say TAB is in tension. Which now leaves us with our final one, which of course is trying to find TBC. Now what we can do is, because we know that this is 50 degrees, then we know that that angle around B is also 50 degrees. I'm going to have to turn this over because I'm out of space at the moment, but effectively what I'm getting at is that TAB, because that is horizontal, is going to be equal to TBC cos 50. Now if we write this out a bit better, then TBC is going to be equal to TAB over that, so we could write it as 20 cos 25 over sine 25 cos 50. Again, keep writing things in sines and coses, you're less likely to go wrong. TBC is therefore going to be equal to 66.7 N. As we know it's positive, therefore we can say that rod BC is in tension. There we have it. We have found the magnitude of all three forces, and we have found whether each rod is in tension and compression. TAC is in compression, which is not a huge surprise, because if TAB and TBC are in tension, then I'm not overly surprised that rod TAC is in compression. Thank you very much for listening. See you.